Hello, in this lesson we shall be talking about the rules that guide us when we're working with indices or powers. Here's the first one. When multiplying indices, if the bases are the same, we just need to add the powers. Let's use numbers to look at this in detail. If we have 2 to the power 3 times 2 to the power 4, it can be expanded to which is equal to 2 to the power 7, but we'll get the same answer if we just added the indices. Here's another rule. When dividing indices, if the bases are the same, we just subtract the powers. In this example, we have to divide 2 to the power 5 by 2 to the power 3. If we expand them, then we can cancel down to have 2 to the power 2 left. We'll get the same answer if we just subtracted the indices. 2 to the power 5 minus 3 equals 2 to the power 2. Here's a third rule. When a power is being raised to another power, we just multiply the powers. Let's see how this works using real numbers. If we have 2 to the power 3 squared, that means we have 2 to the power 3 times 2 to the power 3. If we add the indices, we would have 2 to the power 6, but we can get the same answer if we just multiply the indices. There are two special rules that we need to know. The first one is the power of 0, and it states that any number raised to the power 0 equals 1. Now this is very easy to understand. How do we get a power of 0 in the first place? It's always a power being divided by itself. A to the power 3 divided by a to the power 3 equals a to the power 3 minus 3, which is equal to a to the power 0. But we already know that any number being divided by itself equals 1. So it's going to be the same thing in every situation. A to the power 3 divided by a to the power 3 equals a to the power 0, and that equals 1. The other special rule is the power of 1. It states that any number raised to the power 1 equals the number itself. Let's see how this works. How do we get a number raised to the power 1 in the first place? In this example, a to the power 3 divided by a to the power 2 can be expanded to give a times a times a over a times a, which cancels down to give a itself. Well done. This is how far we will take it to in this lesson. In another lesson, we shall look at negative and fractional powers. It's time to have some practice.